get to the blue graph, or am I making the space wider and my hands are getting wider and wider apart? What am I doing? Are my hands getting closer in or getting wider? What do you think? Closer or wider? I don't here. Let me show you. Maybe you guys don't understand. So if I do my graph, if I take my hands like this to the graph, right? To the red graph, their original graph. And now to get to the blue graph, do I have to make my hands come closer together or do I have to make my hands come further apart? Which one is it? Closer or further apart? Yeah, hopefully you guys can see that I need to take my hands and get closer together. So what am I doing? Am I squeezing in or am I kind of, getting wider? I'm squeezing in, right? I'm compressing. This is what it means to compress, in case you don't know. So compress means to kind of like squeeze in, like, squish in. So that's called compression. So this is called a horizontal compression. So just be careful when it comes to your transformations. A and K can be confusing, but K is usually the most confusing one. And if you don't like this hand trick, that's fine. You can just memorize the numbers. So the values, if K is bigger than 1 or K is less than -1, you horizontally compress, right? And that's exactly the case here. In this case, my K value is 6, which is bigger than 1, so it's a horizontal compression. Well, what does a horizontal stretch look like? Well, what if I did 0.05? No, that's too much. 0.3. All right, take a look at this. Same thing. If I were to take my hands and go back to the original function, the red function, and I put my hands to the left and the right of it, and now for me to get to the blue function, am I squeezing in or am I pulling further apart? Am I stretching? And you can see that I'm stretching, right? Obviously the blue function is stretched up horizontally. So this is horizontally stretched out. It's called a horizontal stretch because my K value is 0.3 and it's between -1 and 1. So a horizontal stretch, horizontal compression. So we went over that. Oh, I didn't do the reflection. I apologize. Okay. So if I were to do a horizontal reflection, how would that look like? Well, the horizontal reflection is just a negative value of K. So I did a negative value of K. And it actually didn't change the graph in this example here. But let's see if I were to apply this horizontal reflection to another graph. And you'll learn that in this course, this functions course, you will be learning 5, 6, 7, 8 new functions. So far, from grades 9 and 10, you probably only know a linear function, y equals mx plus b, and a quadratic function from grade 10. In this very unit, I will be going over square root functions. Well, actually, I don't have too much time, but I will do at least the notes will be going over square root functions and another function, rational functions. So let's do one right now. Let's do a square root function right now. So here we have the original function is square root function. So a square root function looks like this. It's kind of, starts from the origin and then it goes up and then across. And it's kind of going in that, diagonal angle. And that's how it goes on forever. So you just put an arrow at the end. All right. So we got a square root function. Remember, we got to put brackets around the x value whenever we're dealing with our k or d value. So if I do d plus 5, you can see that plus 5 shifted the graph to the left because my d value is negative because it's the opposite. If I do -3, my graph has shifted now to the right. Here, I'll just draw the parent function so you guys can see and compare. So here, the purple one is the original function. The green one is the one that's being transformed. So here, left and right, pretty easy, right? And same thing with horizontally stretching and compressing. It's a bit harder to do the hand trick here, so I would recommend just looking at the numbers. So if my K value is 3, it's a number bigger than 1. That's a horizontal compression. So that's being horizontally compressed. I know it's hard to see, but yeah, it's being squeezed in. And if I K value is 0.5, that means it's a horizontal stretch. It's being stretched out. And if my K value is negative, take a look what happens. Boom. I'll show you again. This is the original function. This is what's happening. See what's happening? It is being reflected, but not up and down, not across the x-axis. It's being reflected kind of left and right, or if there was a mirror on the y-axis. So that's what's happening. So this is a horizontal reflection, right? And the way to describe that is horizontal reflection or reflection in the y-axis, whereas a value is a vertical reflection or reflection over the x-axis. So that is it. That is all the 4 transformation values, and now we're going to apply them to a bunch of questions. Let's do some questions here. In case any of you are wondering, this is Unit 3 transformation. So all of these lessons, 1, 2, 3, 4, 5, I believe, are what's going to be on the quiz for today. And remember, if you can't find anything, you're supposed to go to the actual notes that correspond. So we're in Unit 2 right now. So A1, A2, A3, A4 are what we're doing. And these are, the notes given by, I don't know, e-learning, I guess. But these are my notes, so I like my notes better. Okay, let's close all these. So let us do a question. Let's do a question like this. So here we have function notation, and my g of x is my transformed function, and f of x is my parent function. If you don't know what a parent function is the original function. So f of x is equal to either, say, let's say x squared. That's the parent function. F of x is equal to, say, square root x. That's a parent function. And you learn that in the other lesson, another parent function, f of x equals 1 over x. And f of x is just y, so don't be confused. So these are my parent functions. You need to be able to graph these original functions. If you don't know how to graph these original functions, go through the lessons, watch the video, and they're pretty straightforward. You just have to memorize some key points. So for this lesson, I'm going to be practicing on our square root x function. So this is our parent function for this question here. So the very first thing I should probably do is rewrite this question in terms of an actual equation, like instead of function notation, like an equation. So how to write this as an equation? Easy. See the values inside the brackets? Oh, actually, this is a bad example. You know what? I'm just going to make an example. I'll do that example in a little bit. There's a trick to that, and I don't want to do too many tricks at once. So let's do this one. Let's do this one right now. I'll show you a trick. Don't worry about it. But for now, let's do a simple one without any tricks. All right. So here we have f, our function, g of x, a transfer function. And as you can see, there's a bracket here, and there's a bracket here. There's 2 sets of brackets. What that means is there's a k value and a d value. Remember, only k and d values are within brackets. If there were no brackets, it's your a and c value. So the very first thing you need to do is you need to figure out, well, what's my a value? That's my a value. So I was the number first that's being multiplied. what's my C value? Well, my C value is always, the number that's being added or subtracted.